Adriana, you forgot to remind me to start recording, so I didn't catch that first one. My bad. Okay, hopefully this is IEQ part 2. Hopefully I teed up the right thing. Again, we spend a lot of times indoors. We just saw before that if you're looking at dollars and cents, the dollars for the people inside the building are way more important than the energy and the rent. So we have to pay attention to the health and the productivity of folks that are inside the building. We just talked about indoor air quality, contaminants, ventilation, filtration, things we do during construction and operation and maintenance. So now let's talk about the next one, which is lighting. Right, lighting is a engineered system. So again, you as an architect may or may not get into this level of detail, but hopefully the electrical engineer that you have on your team, if you're doing commercial design, if you're designing an office or a school or a hospital or a laboratory or a retail space, right? They will actually engineer the lighting system. So in the case of a lighting system, we have to choose the appropriate light levels to design for. The foot candles has to do with the type of space, the usage of that space, what is going on in that space, the task, as well as the surface colors, right? What color is the wall? What color is the wall going to be painted? What colors are carpeting? What colors are the system's furniture? All these things are accounted for with good lighting design. Right, we saw this a couple of weeks ago when we looked at lighting sources. So lumens is a measure of the output of the lighting source. And in lighting design, we're actually looking at illuminance, which is how much of that light is actually hitting the surface. Surface is where the work is taking place. Right, in the classroom, it's your desk that you're sitting at, looking up at the teacher and writing notes. Work surface is where, me as a teacher, the instructor is going to stand up and write on the blackboard or the whiteboard, right? All the people have to be able to see those things. Work surface in an office, again, is a desk and the computer and the workstation. So again, in the British units, illuminance is measured in foot candles. Right, so foot candles is how much illumination we want to get on that particular work surface. Again, sorry for a lot of text here on the slide, but again, you or your lighting designer, your electrical engineer will have a table like this in their handbook that will say for a particular usage, what are the recommended levels of foot candles. That little FC there is foot candles, right? So, what's the light level that's recommended? And oh, by the way, we also have to pay attention to the lighting power density, watts per square foot. So not only does your lighting designer have to make sure that we have proper illumination, we also now have to do it within a certain lighting budget, right? So you or your lighting designer has to balance both of those things, providing the right level of illumination and doing it in an energy efficient manner. So in the modern office, much of the work is done in a computer. we now are looking to reduce, what we found is, especially now with modern screen displays, that less light is actually better, allows us to see what's on our screen better. So we want to have lower overhead lighting levels, having some direct and indirect lighting and some task lighting as well. Again, so these are things that you or your lighting designer will consider to try to make sure we have enough illumination at the task, and also stay within our lighting budget, right? You see the task lighting here is helping to light up that work surface, right? The place where the work takes place, and not necessarily lighting up the whole office. Again, we looked at this as an energy strategy, day lighting, getting natural light as deep into the floor plan as possible. This is the case where you as the architect and your design team will have to, you'll have trade-offs, you'll have some balancing will have to take place between bringing in as much natural light as you can, but also to be able to reduce glare so it's still a comfortable place, has good high quality illuminations, not glary, so occupants feel comfortable working there. Right, one of the strategies that can be employed, lots of like any design problem, there's always many different ways that you can achieve an objective as a designer. This particular one is a light shelf. You see it's doing two things. Right on the outside of the building, it's acting to shade part of that glazing from the sun. And also the top of that light shelf is acting to, bounce some natural light deeper into the, floor plate of the building. So again, this is one of those areas, a good example of a place where, you and your design team are going to have to work together to think about a number of different factors and come up with the best integrated design. Right, part of lighting is also lighting control. Again, if we're going to have some natural light coming in, we want to have control of the artificial light sources so they dim in response to the availability of natural light. Right, so what are some of the design strategies for lighting? This is sounding like both energy and quality. Right, we're trying to strike the best balance between an energy efficient lighting design and one that provides a high quality lighting system for the comfort and productivity of the building occupants. We talked about light levels that are appropriate to the task, day lighting, lighting control, occupant control, right? We want to give occupants the ability to turn their lights on and off if we can, fine tune how much light they bring in. Again, in commercial design, lighting is a source of internal gain. So the heat that comes into the building via the lighting system needs to be removed by cooling and ventilation, right? So if we keep energy out with good lighting design, then that reduces our air conditioning load, which, oh, by the way, may already ripple back to the size of the renewable energy system that we need. So these things all fit together. Again, lighting design is a good example of an integrated design process, right, where the building envelope and the lighting system and the electrical system, all those things are all working together. And hopefully you as the designer leading your design team, will make good selections and balance all these factors. Okay, so that was lighting. Let's talk about thermal comfort. Right now I have, you can't see it, but I have a I have a sweater on and it's a little cool in my house because I'm cheap and I run the thermostat fairly low this time of the year because I'm cheap, right? Um, Parsimonious perhaps, so I'm taking care of my thermal comfort with a sweater and a scarf around my neck, right? So that's helping me stay comfortable while I'm not quite at 60. I'm usually running about 67, Fred, is where I typically set my house at. Um, but yeah, so thermal comfort, again, something that you as a designer, as construction professionals, we need to pay attention to, right? We're trying to design and build and operate buildings, maintain buildings that the people who are in those buildings are comfortable. Right? To me, again, I'm a mechanical engineer, so I feel like I'm doing my job well if the people in the buildings that I've designed or that I'm doing the temperature controls for, if they don't think about the heat or the cool, then I've done my job well, right? They don't have to worry about that. They can worry about the 20 gazillion emails they have to answer or their boss squawking at them on the phone or all the other things you have to worry about, right? So thermal comfort is satisfaction with the thermal environment, right? So what are the things that go into that thermal comfort? So one would be temperature, thermal radiation, right? That would be if you sit by a sunlit window, you might feel, uncomfortably warm. If you're in an old house like mine, well, and you saw that we insulated the walls in our house, so we're a little more comfortable. But sometimes if you're in an old house that isn't insulated, you feel cold when you're next to that outside wall at a night, day like today or night like tonight. Humidity, air movement, activity level, and occupant clothing, right? All these things factor into our personal comfort. So in my case, I put a sweater on, an extra layer of clothing on to help me stay comfortable, when it gets colder outside. When it's warm outside, I'm obviously not going to have a sweater on. I'd sit in my short sleeve Hawaiian Zoom shirt, right? Right, so again, it's the role of the project team to evaluate the building, its design, its occupancy activities, and create conditions that will be acceptable to 80% of the occupants, right? We're never ever going to make everybody happy. That's really, really hard. There's always going to be someone who is an outlier, right? But our goal is to have the vast majority of occupants be satisfied with the thermal environment that we're creating for them as designers, builders, or operators of buildings, right? We all have a role to play. So again, the design team will again look at this ASHRAE standard 55 that has kind of objective, allows you to evaluate some of these factors. Also in LEED EQ world, we'll look at giving the occupants control of their thermal environment, right? That's the way that LEED looks at this. Is one of the ways that we provide a satisfactory environment to people in the building is by giving them some degree of control over the conditions in their buildings. We have some ways of doing that, right? We have a system called a UFAD, or underfloor air distribution, or a raised floor. In this case, the air is being distributed from below, and this gives individual occupants the ability to control the amount of ventilation that they get into their individual cube, right? They have a little swirl diffuser on the floor, and they can adjust, he or she can adjust how much air is coming into their cube, right? This would be an example of where we're giving occupants control. Here's another way that we might give occupants control, right? This is actually a little phone app called Comfy. Actually, the company that I worked for bought Comfy a couple of years ago, so now it's a Siemens company. I work for Siemens, so Siemens bought Comfy, but Comfy is an app that you can have on your phone. So if you happen to work in an office building that has the system, you can load the Comfy app on your phone, and then you can use your phone to vote whether you want to raise or lower the temperature or raise and lower the lighting level. And then the Comfy software, tries to break the tie if multiple people are asking for things that conflict with one another, right? So this is a case of, a high tech or a smartphone based way of giving occupants control of their lighting and temperature. So that was thermal comfort. The other thing that we do in the control of indoor environmental quality is look at acoustics. Acoustics is noise. So again, this is something that we do from a design standpoint. So in an open plan office, we want to be able to concentrate and communicate without having distractions from our coworkers, shouting on the phone next to the cube next to us, trying to collect money or whatever. We want to make sure we don't have distractions from mechanical equipment noise. We don't want distractions from noise from outside the building. Right, so proper acoustic design helps provide satisfaction for the occupants of the building. It improves their ability to communicate. So again, you as a designer, you can manipulate the interior finishes. You can make sure that your mechanical engineer designs a high quality mechanical system that doesn't have a lot of noise. And you can look at the reflectivity and types of building surfaces that you have. Right, you might design in some acoustic treatments, right, things to dampen or absorb sound. This could all be part of strategies that you employ as a designer to make sure that you're providing a good indoor acoustic space for the folks that in your building. Right, LEED is going to have some terms. Right, there's always terms and things that you have to keep track of in LEED. So a lot of these things will be look at whether it's a regularly occupied space or an individual space or a multi-occupant space, unoccupied space. Again, you might have different design strategies depending on how the space is being utilized. Right, again, here's I had this, sorry, I had this in the last one. I should have taken it out of this one. Again, we as designers are thinking about all this stuff, thinking about COVID and our design and operation of buildings. Health and safety has always been important, even more so now. What are things going to look like? What is the open plan office going to look like when this is all done? I don't know. Are we still going to have open plan offices? Are we going to put everybody back in cubes? Right. I've been in the world of work long enough to know at one point when I started my career, we all had little cubes that had high walls, and slowly those cube walls came down, and eventually we got to open plan offices, and we got to offices where there were no cube walls, and we could easily go back and having divisions between us again. Who knows? Right, here's our IEQ scorecard. Again, looking at design. Same thing as always. 16 credits possible. Prerequisites. Prerequisites are required, must do. Credits are optional. You can do. do enough of them to achieve the score that you want to get in your project. What are some of the things that we will do in, I think I had this slide before, my apologies. Again, repetition in operating and maintenance, the folks that run the building, operate the building, right? They're going to monitor the amount of outside air they bring in. You can measure how much outside air you're bringing in. You can measure CO2 levels. As I said before, CO2 is an indicator of occupancy. We can adjust ventilation levels in response to CO2, although we're getting away from that a little bit now with COVID, right? We're just bringing in a lot of outside air. Obviously, we want to change filters, maintain our sensors, right? We have temperature and humidity and CO2 sensors. We have to make sure that all that equipment, all those sensors are in operations, or they're calibrated, prohibit smoking, green cleaning program, entryway systems, integrated pest management, right? We talked about all those things. And again, here is our lead O&M EBOM scorecard for operations. Again, we have prerequisites, things that we must do, and then we have credits. Okay. Any questions? I've got a couple minutes here to try to wrap up the semester in 12 or 13 minutes. We'll see how effectively I can do that. Come on. There we go. Okay. Well, it's our 15 or 16 weeks has gone by quickly. Next week is the final exam. In the few minutes that I have left here, I thought I would try to summarize and hit on some of the highs and lows, important points from our work this semester. I'm going to, well, first of all, I have to write the final exam tomorrow. And then once I do that, I will probably build out this slide deck a little bit more. So I'll put this up under the final exam section on Blackboard. Hopefully get it up tomorrow. So give you some idea what to think about. The final exam is going to be, it's going to be written essays. So I'm going to try to have you think about and analyze and put things together, as opposed to just reciting facts like we did at the midterm. So, but yeah, I'll try to give you a little bit more room as to what you should be thinking about. So anyways, seems like a long time ago now. We've had a lot of things that happened to us in 2021 that reminded us that we live in a changing climate, right? This is floods in Germany, extremely heavy rainfall in a short period of time, destroyed, lives lost, property destruction, right? A changing climate. Here's some firefighters in California, right? I trying to battle, I think this was the Caldor fire. I said Cook County's about 1 million acres. When I looked up the numbers last night, I think we had about 6.5 million acres of land destroyed by wildfires in the West this year in 2021. So, think of 6 Cook counties got burned up due to wildfires in the Western United States. Right? Those are some of the impacts of global climate change. right? Atmospheric CO2 levels have increased dramatically due to human activities, right? Humans is us, right? We are the cause of this. We as Americans in the US, right? We have the largest historical share of emissions, so it's going to be, you know, in fairness to the rest of the human beings on the planet, we have to be the ones that help solve the problems that we've created, clean up the mess that we've made. We knew that due to the greenhouse effect, that we're trapping, you know, that CO2 in the atmosphere and the other greenhouse gases, the methane, et cetera, right? Less of the energy that comes from the sun is able to leave again, so that's warming up the atmosphere. Right? We know that more heat in the atmosphere means warmer temperatures. You know, we're melting glaciers and polar ice caps, less sea ice in the Arctic, warmer oceans, rising sea levels, right, et cetera, right? When we had these questions on the midterm, all of you could think of many, many good examples of some of the impacts that we made on the environment. Right, we looked way back when about comparing human footprint to the carrying capacity of the Earth. We say that our human use of resources is roughly 1.6 Earths, 1.6 times the Earth's ability to provide the resources and to absorb our wastes, right? So just like the guy in our little YouTube said, right, we're spending down our bank account. We actually spent down our bank account. Right now we're running up credit card debt. We obviously can't do that forever. So we have to change things. Here's our levels of carbon dioxide emissions. With population growth and rising incomes, carbon emissions are continuing to rise, right? Population of the world is growing. Lots of citizens in countries like India and China and the developing world and Africa, right? They all aspire to the standards of living that we in the developed world, in the United States and the European Union, right? All the developed world, you know, we've enjoyed these standards of living. Other human beings aspire to those same standards of living. So that's presenting a problem. Right, here's our temperature information. You know, the x-axis is the last 2,000 years, right? So this would be the Common Era, AD, the way we used to talk about it. So the last 2,000 years of the Common Era, you see that in the last 20 or 30 years, average temperatures on the surface have warmed considerably. Right, 1991 is not that long ago, right? That's about when my kids were born. You know, in the lifetime of my children, you know, we've warmed the Earth, what, 0.6 of a degree Celsius? That's a lot. That's the same. Most of you are probably even less than that, less than 30 years old. So, right, a lot has happened, right? So we warmed the Earth about 1.1 degrees Celsius over pre-industrial. And we have our Paris climate goal of 1.5 degrees Celsius, right? So unfortunately, that little arrow is trend line is heading up dangerously rapidly, right? So what are we going to do about that? Well, this was the International Energy Agency and lots of other folks have come out with the same sort of thing, right? To stay within that 1.5 degrees Celsius, that is our Paris, or our goal that world leaders have set for us. We have to get to net zero by 2050. So that's the roadmap. That's our goal as construction professionals. Right. So on this slide, I highlighted the things that are green. You know, green is buildings. That's what we do. We're construction professionals. So those are the things that are in our swim lane. Those are the things that we're going to focus on, you know, going forward in our careers. Right. We want to get to 50% reduction by 2030, net zero by 2050. A lot of bold things that we have to figure out, that we have to do. Right. It's a challenge. You know, no new fossil fuels in buildings by 2025. That's not that long. You know, we got to figure all that out in the next couple of years. All new buildings net zero ready by 2030, et cetera, right? I think the more challenging ones for me, because we have a lot more existing buildings than we do new buildings. Yeah, I think we kind of sort of know how to make all new buildings net zero ready. But I think what's more of a challenge is we have a substantial stock of existing buildings that are all going to need to be retrofitted and decarbonized as well, right? I think that's as much of a challenge, or probably more of a challenge than new construction. Right? We looked at the 3 pillars of decarbonization, the things that we have to do in one form or another to get the fossil fuels out of our buildings. And this is the operational carbon. Right? We looked at the top of this session about the embodied carbon. Right? We have to think about both operational carbon and the embodied carbon. So those decarbonization is energy efficiency, renewable energy, and electrification. So some form or fashion will be doing all 3 of these things. You know, part of electrification are things that we will have in our control. You know, having an induction stove rather than a gas stove. You know, having a heat pump rather than a furnace. And part of electrification is what other people do on the electric grid. You know, swapping out coal plants for solar and wind turbines. Right. So we control a lot of this stuff. Right. Again, here's our 3 pillars: efficiency, energy efficient new construction. Well, it also means energy efficient retrofit, deep energy retrofit, electrification, right? Getting the fossil fuels, no fossil fuel based systems for heating, cooking, etc. And on-site renewables, either on-site or off-site. Again, getting fossil fuels out of our buildings. Right, what are the good news? At least my take on all this. What's the good news? The good news is that, you know, there's nothing, for the most part, there's nothing here that we have to invent. We don't have to wait for a magic bullet. You know, all the technologies that we need are already here. We know about how to insulate and have high performance windows and passive house and heat pumps and solar panels and windmills. All this stuff already exists. We don't have to wait for something to be invented. We can, you know, master these technologies and these systems, and we can deploy them. You know, what do I see as the challenge? I think the challenge to me is scale, right? Scale means that we don't do this on just 1 or 2 projects, that we do this on every project. You know, not a few one-offs, but every building and every project. So I walked down the street to get a sense of the challenge of scale, right? So in the next block over from me, right, this guy, Tom Basadilli, who is a local architect who kind of specializes in I think now he's kind of made it part of his practice to specialize in high performance and low carbon architecture and design, right? This is his house. He's over the next block from me. So he's got a sign up in front of his house that says, this is a This is a decarbonization project, right? It's a deep energy retrofit. So you see my shadow as I was standing there the other afternoon, thinking about all this stuff and how I was going to wrap this semester up. So I took a picture of his sign and a picture of his project, right? You see he's got solar panels on the roof. He's got additional insulation. He's got a heat pump, right? So he's in his project, you know, is doing a deep energy retrofit and getting the carbon out of his building, which is great. But right, I looked down the street and his house is only one of, I think I forgot, I should have counted better, either 40 or 42 similar houses on that block. So when I talk about scale, I'm saying that, yeah, we can do, you know, we don't have to figure out how to do one of these. We have to figure out how to do, you know, 40 or 42 of the same project, right? That's our challenge. Our challenge is how do we go from this as a one-off, you know, to this as something that we as construction professionals can deliver effectively and cost effectively to all the other homeowners that live on this block and lots of other blocks just like this, right? That's our challenge. So again, why do we want to undertake this challenge, right? Well, we have to think about all the other human beings on the planets, right? Remember, we met this gentleman from Bangladesh who unfortunately, you know, had to marry his young daughter off because his house and his farm had been swallowed up by the rising sea levels, right? We have to think about, you know, as we're facing all these challenges, think about all the other human beings that share the planet with us and make sure we're doing the best by them as well, right? Here's our challenge of sustainability, right? All is every human. Every human has, you know, wants to have economic opportunity, wants to have development, and we have to do it within the limits of the planet. So those are our challenges. Okay, well, wrapping up a class in a virtual environment is a little bit strange, right? Because I don't get to look out across all of you sitting in the classroom and be able to gauge your reactions. But I just wanted to say that it's been my pleasure to teach you this semester, and I hope that it has been beneficial to you. Again, we'll have a I'll